Hello! Today we're going to dive into one of the most powerful tools in algebra. We're going to talk all about the quadratic formula. By the end of this video, you will be able to, first, identify the coefficients and constant in a quadratic equation, and second, use the quadratic formula to solve for x in any quadratic equation. This formula can look a little intimidating at first, but don't worry, we'll break it down step by step. Let's get started. First, let's understand what a quadratic equation is and why we need this formula to solve it. A quadratic equation is a polynomial equation of the second degree. This means its highest exponent is 2. The standard form for a quadratic equation looks like this. It's written as a times x squared plus b times x plus c, all equal to 0. Here, x is our variable, the value we want to find. The letters a, b, and c represent known numbers. The a value is the number, or coefficient, that is multiplied by the x squared term. This coefficient a cannot be 0 because if it were, the x squared term would disappear, and it would no longer be a quadratic equation. The b value is the coefficient of the x term, and c is the constant term, the number that stands alone. So, a quadratic equation is any equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are just numbers, and a is not 0. Solving a quadratic equation means finding the values of x that make the equation true. These values are also called the roots, or zeros of the equation. There are a few ways to solve these equations, but the quadratic formula is the most reliable. It works every single time. Here it is. The value of x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This formula gives you the roots of the equation in terms of its coefficients a, b, and c. Our goal is to simply plug the correct values for a, b, and c into this formula. Before we can do that, our equation must be in the standard form. Ax squared plus bx plus c equals 0. This is a very important first step. The equation has to be set to 0. If it isn't, you need to rearrange it first. Let's work through our first example. Suppose we want to solve the equation x squared plus 3x equals 4. Our first step is to write it in standard form. Remember, that means we need to set the equation equal to 0. To do that, we can subtract 4 from both sides. Now our equation is in standard form. It looks just like ax squared plus bx plus c equals 0. Our next step is to identify the values of a, b, and c. Looking at the x squared term, we see it's just x squared, which means its coefficient a is 1, the coefficient of the x term b is 3, and the constant term c is negative 4. Make sure you get the signs right. Now that we have our values for a, b, and c, we can use our formula. We'll substitute a equal sign 1, b equal sign 3, and c equal sign 4 into the quadratic formula. Let's plug them in carefully, one by one. We get x equals negative 3, plus or minus the square root of 3 squared, minus 4 times 1 times negative 4, all divided by 2 times 1. Excellent. Now we simplify the expression. We'll start with what's inside the square root. This part is called the discriminant. 3 squared is 9, and negative 4 times 1 times negative 4 is positive 16. So inside the square root, we have 9 plus 16, which is 25. Now we can simplify the square root of 25, which is 5. So, our equation becomes x equals negative 3 plus or minus 5, all divided by 2. Notice the plus or minus sign. This is very important. It means we have two possible solutions for x. One solution uses the plus sign. X equals negative 3 plus 5 divided by 2, which is 2 divided by 2, or 1. The other solution uses the minus sign. X equals negative 3 minus 5 divided by 2, which is negative 8 divided by 2, or negative 4. So, the solutions to our equation, x squared plus 3x equals 4, are x equals 1 and x equals negative 4. These are the two values of x that make the original equation true. Let's try another example. This time, the equation is 2x squared minus x equals 10. Just like before, we need to put it into standard form first. We'll subtract 10 from both sides to get 2x squared minus x minus 10 equals 0. Now, let's identify a, b, and c. The coefficient of x squared a is 2. The coefficient of x is negative 1, so b is negative 1. And the constant term c is negative 10. Now we substitute these values into the quadratic formula. Remembering that b is negative 1, we get x equals negative 1 plus or minus the square root of negative 1 squared minus 4 times 2 times negative 10, all divided by 2 times 2. Time to simplify. Negative 1 is positive 1, negative 1 squared is also positive 1, and 4 times 2 times negative 10 is negative 80. So we have x equals 1 plus or minus the square root of 1 minus negative 80, all over 4. 1 minus negative 80 is the same as 1 plus 80, which is 81. And the square root of 81 is 9. Again, we have two solutions. The first solution is x equals 1 plus 9 divided by 4, which is 10 divided by 4, or 2.5. The second solution is x equals 1 minus 9 divided by 4, which is negative 8 divided by 4, or negative 2. Let's quickly review the steps we've covered today. First, make sure your equation is in standard form. ax squared plus bx plus c equals 0. Second, identify the values for the coefficients a, b, and the constant c, being careful with their signs. Third, substitute these values into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all over 2a. Finally, simplify the expression to find the one or two solutions for x. And you're done. So, we've achieved our objectives. You can now identify a, b, and c, and you can use the quadratic formula to solve equations. It's a fundamental tool that you'll use a lot in mathematics. Thank you for watching, and keep practicing.